So, sorry for the delay. And now the talk, plants and machines. Let's start.
Thank you very much. We are very, very honored to be here. This is us too from the Plants and Machines project. It's quite fresh image of us doing field research. By now we are 4 people. We have a friend who helps us learn programming and another one who supports us with other critical issues. But it's actually this garden where everything started out about 1 year ago, a little bit more. And it was an equally dark and very, very sad and cold night when we came up with this question that how is it that everything in nature in this hemisphere sucks so badly at being green? And so we thought like, okay, there are some solutions. Some waste 600 watts and then others are producing red, blue light, which makes plants look sick from the beginning. And we thought we could solve this problem. And so we made a little rendering and thought this is really nice. It was planned to be 1 cubic meter for our little garden. And yeah, we planned everything from 2 water tanks for the wastewater and the fresh water and where the water should go. And in the middle we planned for a pump. So we were almost done until we met a product designer who said, this shape is so expensive, you can just go file bankruptcy. So we wouldn't do it anyway, but then there was this nice little party and there were these boxes, and with a little bit of social engineering and building the lightning, we eventually ended up with one of those very beautiful boxes. So that day we adapted our plan a little bit, and we would now have fancy doors to open and close the garden. And we set immediately out to have this plan because it was fully working. You see, we have a plug and we have joints and even a little plan for what we wanted to do with the electricity and computing. So we put it into work and we asked the guy from the machine realm whether we could do it at this place, and they said like, okay, this is a very old building. It's like 1,000 liters of water you want to play with, and basically we have all our technique here and you are not welcome. So we've had to find a new place, and
this place was actually a garage, and there it didn't matter if we spilled tons of water or burned some fuses. Nobody would yell at us. We could pretty much do whatever we wanted. And the plan was to fit the tank through this door you see in the picture, which didn't quite fit. We made it fit eventually, but we thought you can't expect from anyone to hack a door first before hacking your garden. So we thought, maybe we should scale it down a little bit more. Maybe we should make it a little smaller, and yeah. But then, about a year ago, I think it was the 24th of December, we went shopping and we got ourselves some heaters for the garage and some of the first boxes we used for prototype or for proof of concept. And of course we bought some Christmas trees for our girls. So this is basically it. This is the first prototype or the proof of concept, and it consists of a water reservoir down here, the grow bed up here, and a top case covering it all. And one thing we did was to put fish inside the water reservoir to make it an aquaponics system. This way, microorganisms living inside the grow bed can generate or can convert toxic substances from the water to nitrate to actually fertilize your plants. So With this kind of system, you would not have to balance fertilizer or nutrients inside your system. Pretty much runs on its own. The system, the aquaponics system, contains a closed water loop. There's no water loss in this kind of systems, except that due to evaporation. So the water gets pumped up from the fish tank up to the grow bed. The microorganisms living there take care of the toxic substances, convert it to nitrate. Plants take up the nitrate and return the clean water down to the bottom, to the fish tank. This is pretty much our hardware stack for our first prototype. You can see here an Arduino that is connected to one sensor we had at this time, a temperature and a humidity sensor for above the grow bed, and is then connected to some relay boards that are switching a pump, a heater, a bubbler or aerator, and the light. The Arduinos then pretty much, or could be considered the autonomous nervous system of your garden, because it acts on its own. And the Raspberry Pi is the brain of the system, where you log all things that are happening in your garden in a database, and the Raspberry Pi also gives you an interface to control several settings of your garden. One little problem we had to solve was we need to make the Arduino aware of time, because we had some time essential or time critical events like switching lights on and off, or like the flood cycle for the system. And you could have just put a clock inside the Arduino, but we decided we would make this with software interrupts, where you actually use the microprocessor of the Arduino with its full, beautiful 16 megahertz to count up to a specific number that defines a certain time in in your system. And so when this number is reached, the timer compare vector gets called and triggers your functions.
So we were done with our first proof of concept, and we thought, oh, this could really be a robot you have at home, and it's actually was really going very well. What we grew inside, we threw a lot of energy at the system. That's true, but therefore we got a lot of green. And one problem with our approach, because we wanted it to be so easy handleable, was if you look at the opening, this was the biggest opening you would get if you would be one person. So it was very, very wonderful for the teamwork, because always one person would have to hold it up and the other person would do the gardening, and then we switch, take turns. But eventually we really produced nice things, and now a few months ago, like real innovation takes time, we figured that with one zip tie you could just flip up the top and do this all alone. So we are quite happy with the system, and it really worked well. We had to do nothing. So yeah, we started with Kresse, then we grew tomatoes and radish and all this stuff. It was cute. But then we thought, like, oh, we can do this much better, because with more technique we can solve more problems. And so we came up with this plan of putting the bot back into botanics and making and make it really complex. So by not stacking it on top of each other, but by verticalizing the setup and giving the water reservoir its own Arduino and the plant part its own Arduino. The thing is, you can, with one such a water reservoir, you can in theory nourish many of those little plant boxes, and we wanted to see this happen. But before we wanted to put lots of technique inside, and we wanted basically to have a rack in the top, as you can see, that would measure the distance to the plants and then adjust. And so running the system felt really like printing food. So it would slowly go up, very, very slowly. We were not there when it happened. But yes, so but the rack had to be engineered, and we started to experiment with LEDs and storm making machines. So we put like really lots of ventilation systems inside, and the sensor you can see on the right hand side. There's the distance sensor, and then there's a light and humidity sensor, and so on. But if you really want to engineer a cute garden, you don't want your plants to miss out on all the kitsch of nature, and that's why we even added a humidifier and said, "Fog it. This is really going to be pretty." It turned out this humidifier was way too much for our cables. It burned everything, but it was pretty for one. So, yeah. We made huge progresses, because from this system on, we never had to work together to feed our fish, which we were still doing every day by hand. And we added a pH sensor, because we wanted to find out more, and there are so many little places where you can tweak your system, like with the amount of oxygen you can make your fish fitter, or with less oxygen they swim higher. And But we were always really aware of giving them high quality life and making it really nice for them. We gave them existential experiences, and
one thing when designing such a system is you have to make sure everything is water and airtight. But because like the standard or normal connector sockets you would use to attach those solenoid valves, for example, are made out of metal, or made out of metal that is not stainless steel, there's some danger that you get toxic substances inside your system that will harm your fish, your microorganisms, your plants, and unfortunately, or could even harm you when you eat the fish or the plants later on. So, one solution when something is not watertight would be to just drown it in epoxy, which we did here. Of course, this is watertight now, or this was watertight, but if you run into a problem and had to switch some hardware, you would have corpses laying around in your system, because this middle one is cut out, it's not functioning anymore. And of course, when we said we wanted to make this a full-blown system and wanted to make it really cool and pretty and put lots of sensors and actors in there, we didn't realize that it eventually, in the end, would look something like this. So it would be a rather complex system in the end. And this is the data that gets sent from the Arduino to the Raspberry Pi, just from the one grow bed you've seen in this picture. As we said before, modularity or accessibility was really important, because you don't want two people when you're gardening. So we had to make every connection like pluggable like these. We used ATX and USB connectors and Molex connectors to wire up our sensors and actors, and to be able to take off the top very easy. But still, there's lots of cables, and we actually had to use separate box just for the power supplies. We had 4 different power supplies, because if you start building things, you gather experience, and the next time you do it right. But at this point of time, we had a lot of power supply units.
Yeah, so this was not so elegant as we imagined, but on the other hand, also very, very expensive, and we thought, like, this is not really what we want, and if we want people to help us, we will not go this way. So we thought about what we did, and we thought, like, there were really nice things we had in the one and in the other system, and we thought the first one was much nicer to hack with, because even if your code fails, you could not really spill water somewhere or get in contact with electricity. So we thought we keep the modularity of the second one, but keep the setup of the first one. I'm afraid this. And it would look like this. It was much bigger, much bigger. So it's actually like this size right here. And so we took a few tubes and used gardening steckers. for making the boxes airtight and fit on top of each other, but while still being handleable. And we also invented the double Molex steckers. I don't know. This word is going to haunt me. And we were really happy when we came up with eventually with this enormous bot. It had an off switch which was very handleable, and otherwise it was very simple, but it worked very well with the chili we had planted before. So we have proving pictures for the happiness of the fish. We switched them for bigger ones. It was actually an accident, but the guy in the shop said they are extra dirty. So we thought that's a good thing. And yeah, actually we have extra huge chili now. And then there was this message that hit us. We basically were never expected to come up here. And that was the moment when we got really nervous. and thought like, okay, let's try it again and make it really beautiful and perhaps get some help from other people too. So we started a kitching process where we wanted to break down everything onto 1 voltage, which more or less worked well, but because we avoided so many warranties on the way there, we thought like, we never really liked the water heaters because they have inherent safety and that is less control for us. And so we started to design our own heating things. Which we would fill up with really lots of silicon, which was very expensive and not food safe either. So we thought we had to do it again. And would you like that?
Yeah, so we done it again, and we pretty much stuck to the basic design of a heating element, which is resistive wire wrapped around a steel coil or metal coil. We put it into an aluminum pipe. We sealed it off with super at the ends, and then put it into a plexiglass pipe, which are then capped by wooden caps. Yeah, and it works quite nice. One thing we had to solve though was the feeding process of the fish, because well, we were still feeding our fish every day unless we forgot this. But and we made a really nice rendering of a fish feeder, and we thought about printing it out and rapid prototyping it. But when we calculated the cost for this, we said it was another bot. So we decided to, just do it in one day. Do it with a small little box as a reservoir for the food. Have a little motor on the outside of the box, which has or is connected to a rod that rotates, takes away some food, and puts it into the fish tank. So in this bot we have automated feeding now. And of course the wiring too is a lot more organized. We used ATX, 24-pin ATX cables all the way. Everything is connected up to there. And the hardware stack stayed the same as in the prototype before. It's a little bit more complex. We're working on sorting things out right now. We're actually trying to design a Raspberry Pi board to get rid of the Arduino, and we're implementing a bus system for our sensors. So, yeah, but still.
So we are very used to adapting rapidly. We wanted to give you a demo, but somehow we have issues. It's good that we are late. We don't have issues anymore. So this was the moment when we thought we need help, and we adapt again, and we found a friend who is basically in gaming, and he loves interfaces, and he really takes time to make code look nice and stick. And so we try to corrupt him, because like we are poor students, and we thought like, okay, perhaps if we say he gets the spot, he would help us develop a really nice interface. So we would ask him up here and give you a little demo if he's in the room. Yeah, okay. How does it work? Yeah.
Next.
No.
Hello. Hello, I'm Dex. I'm the guy. Yeah. This is my bot. And yeah, the guy said something about technical difficulties. I just fixed them right there, and I'm now switching to the browser and hopefully
With the escape button.
okay, with the escape button. This is a Mac. I don't have a Mac. Yeah. So yeah.
Yeah.
So okay. Okay, so I can take this.
Nee,
Thank
du hast kein Screen hinter dir.
Ich habe
So
kein
the demo is
Screen,
only for you.
Yeah, okay, I can do the demo for myself now. This is probably this button, I guess. Yeah, should be.
If it stays on this side of the
Let's go for it. Yes. Okay. So now I have the screen down there. All right. So the first things I got asked from the guys when they came to me was, how can we make this 3 boxes something you can love, something you really want to have as your gardener? And for this, we somehow needed a face for this thing. And as I'm still a programmer and not a designer, I made an ASCII face, which is now, for now, the face of the bot. And what we learned so far is, what I learned when I did some animation was that if you have a face, you need to make it blink, otherwise it's no face. So the first thing I did was write an ASCII bot class, which has nothing to do with the bot at all, but it makes a nice face. And it should, if everything works, show at some point. This is, the bot does its own AP for now, so it runs in backup mode and makes a small tiny ASCII face. And the first thing it asks you, what's your name? What's my name? So you can name it, then name yourself as the guy who built it, and then later on it's meant to guide you through the setup process to actually build the bot from the Arduino and what you got for now. For now, we have this and the prototype interface. So I'm switching back to the prototype interface. Did it blink? It didn't. Oh well. It will blink hopefully here. I can. Come on, be nice. Yeah, okay. This is this. And yeah, this is another iteration of this thing when I was just working for it. And this is the interface we have now. Usually there's a webcam picture, yes, a webcam picture where you can see what the cam is picking up and pointing down. And then, yeah, we have posted in manual override because it just started up and you don't want it to start spewing food out or whatever. So, how do we start with this? This is, we have to set a point. So for now we have the plant, which you can see here. For now we have the capsicum Chinese, which is actually inside the bot. You then can set reference values for each of the things, which will hopefully update for a graph. So for example, this capsicum Chinese needs a reference temperature of 30 degrees. So we can set the 30 degrees and pass it on. And the bot will try to then either heat or not heat the system to get to those 30 degrees Celsius. The same can be done for more stuff, like humidity is, if the fan spins up to get more air in, when we will find out if the humidity is a bit bigger, there's more humidity outside. So we will implement some feature where you can tell the bot the location and the latitude and longitude, and it will grab weather from it. And if it knows it's outside, you can either pump air in if you need more humidity, or out if you hope you can somehow solve this problem. Yeah. Then you have the light intensity. It's rather bright. It can be brighter. I will show you. And yeah, the soil temperature. There's sensors in the soil and there's sensors in the water, and of course there's heating and everything. Also, we have the awesome machines part where you can actually turn things off and on again. It's like the delay from the sun to us is 7 minutes. Here it's a bit shorter. And there's, okay. Now we can also flood, which shows that we can pump the water from down here to up here. And at some point it hopefully stops because it reaches the water sensor. I'm guessing, I'm not pushing, look, no hands. And it stops. Yeah. From here, so this is what we have for now. And what I want to have is some kind of botnet where the bots can exchange information about how to grow the plants, and the actual people behind the gardeners can share recipes or how to do this. And for this, I will hand it back to what machine learning paths we actually want to have.
Thank you very much. We miss all the precious time. We would have loved to tell you so much more. But hopefully next year, or in the coming year, we will be able to release the software. So we get people who help us collect data, and perhaps as together we could make a foundation of public knowledge in form of data where you can statistically analyze what is really good for plants and fish, and make this accessible for many people. This is our big hope, and then we are very hoping that people find out whether a speaker in a robot like this would make a difference for the fish or the plants.